Welcome all. In this video, we are going to talk about spectroscopy. Spectroscopic technique you might have studied in your 12th. It is the basic plot of intensity of the radiation with the wavelength. Intensity of the intensity of the radiation with the wavelength. If you are going to pass white light into an prism. So if you are going to pass white light into a prism, so the light would be we will observe 7 different colors which comes out from the prism. Okay, when you are going to plot the wavelength of the colors with the intensity, we get a spectrum. Okay, so basically wavelength is represented as lambda. Okay, length between the two consecutive troughs or two consecutive crust of a wave is called as a wavelength, and normally it is expressed in terms of the meter. Okay, so this is one term in the spectroscopy. We will be studying that is lambda is the wavelength. Lambda is called as a wavelength, and nu is the frequency. Okay, number of radiation passing through, number of waves passing through a point per unit time per second is the frequency. Frequency is equal to c by lambda, where c is the velocity of the light, and the lambda again we know is the wavelength, and its unit is second inverse. Okay, velocity of the light is meter per second, and lambda is in meter, so meter will cancel, and nu would be expressed in second inverse or sometime in a hertz. Okay, and E is equal to hc by lambda. So E is equal to hc by lambda, where h is the Planck's constant. So these are the basic things you must know about the spectroscopy, and there are two types of spectroscopy. One is the absorption spectroscopy, and another one is the emission spectroscopy. So absorption spectroscopy is normally when a color or when a light is observed by the substance, then it is called as an absorption spectroscopy. So absorption spectroscopy normally occurs in the absorption spectrums. There are 3 types of absorption spectroscopy. In absorption spectroscopy, you can have absorption spectra, you can have a line absorption spectroscopy, a band, a continuous. Okay, line absorption spectroscopy is when a substance observes at only one particular wavelength, then it is called as an line absorption spectroscopy. When it observes a band of wavelength, then it is called as an band spectroscopy. When it observes continuously all the wavelength, then it is called as an continuous absorption spectroscopy. And there is an emission spectroscopy. Next is emission. Emission is when the light is emitted. For example, our tube light, sodium vapor lamp or sun. So they emit radiation. So these are called as an emission spectra. So they gave emission spectra, and you got line, again band, and continuous spectroscopy. So if you take an spectroscopy, so the spectroscopy will cover an entire spectrum, that is from the gamma, which consists of 10 to the power of minus 13 meter as wavelength, to radio waves, which consist of 10 to the power of 5 meter as wavelength. Okay, so wavelength is very less, means energy would be very high, frequency would be very high. So that is gamma radiation. Gamma radiation has a very high frequency, very high energy, and radio waves has a very high large wavelength. So it has a low energy and low frequency. So basically, if we talk about a spectrum, we can cover the entire spectra, that is from the gamma regions to radio waves, but we are not going to cover in this module, or for our syllabus we are not going to cover all the radiation. For example, we are not going to cover gamma or X-rays. Okay, so we are basically going to cover UV, IR, UV radiation, UV spectroscopy, IR spectroscopy, atomic absorption spectroscopy. That's what we are going to next come, and flame spectroscopy. These are the techniques that we are going to study in this module. So there are again, if you are going to consider a spectroscopy in terms of atoms and molecules, there are two different types of spectroscopy. One is the atomic spectroscopy. Another one is the molecular spectroscopy. So atomic spectroscopy, as the name suggests, okay, it deals with the interaction of the electromagnetic waves with the atom. And when you are going to talk about molecular spectroscopy, it is going to deal with the interaction of the electromagnetic radiation with molecules. Okay, atomic spectroscopy basically occurs in the atom, that is by excitation of the electrons in the atom, whereas molecular spectroscopy in the molecules, there may be some other transition. For example, there may be a vibrational spectroscopy, there may be a rotational spectroscopy, there may be an electronic spectroscopy. That is, the spectroscopy may arise due to the difference in their rotational motions, due to the vibrational motion, and due to the electronic transition. Okay, atomic spectroscopy is little bit easy to understand. It's an line spectra, whereas the molecular spectroscopy, because molecular spectroscopy we have got a rotational, vibration, and also electronic, so it becomes a little bit complicated. Okay, so these are the basic idea about the spectroscopy. Again recapping, there are when an electromagnetic waves, EMR, electromagnetic radiation or electromagnetic waves is observed or emitted by a substance, we get a spectroscopy. Okay, spectra is a plot of wavelength, or you can also have energy or frequency in the x-axis with the intensity of the wavelength in the y-axis. So okay, so if there is an absorption spectra, then there will be a decrease in the intensity of the radiation of the particular wavelength when a particular wavelength is observed, or when a particular band is observed, then there will be a decrease in the intensity of the radiation in the particular band. Whereas in the emission spectra, there will be an increase in the emission, means when the light is emitted, basically when the EMR consists of visible radiation, IR, UV. There is a spectra which you might have studied in your 12th, starting from the gamma radiation to the radio waves. Okay, and dividing the spectra in terms of molecules and atoms, there is an atomic spectroscopy which is given by the atom. Basically, we are going to study the atomic spectroscopy in AAS, atomic absorption spectroscopy. In the flame emission spectroscopy, we are going to talk about the emission of atoms, that is basically sodium, potassium, emission of radiation from the atoms. And there is a molecular spectroscopy. Molecular spectroscopy is a little bit complicated. So because there will be because in molecules there can be a rotation. So when the molecule gets excited, the rotation may be very fast, or vibration may be very fast. So there is a vibration spectroscopy, and there is also an electronic spectroscopy. Okay, this is for this video. We will meet in the next video with Beer-Lambert's law. Okay, see you then. Bye bye.